tomorrow we can all get back to meeting physically, and we'll be able to meet up in person. But up until then, I think we're all trying to arrange events as things go. So get involved if you can. PyData UK, force of habit. PyData globally, PyData UK, and each individual PyData chapter abides by a code of conduct. It's important to remember that PyData is a professional meeting space. So yeah, read up on the code of conduct, make sure you understand it and abide by it. For more details about the code of conduct and to understand the full and to read the full version, the link's just there. So globally, and thanks to Sam from Edinburgh for these slides, we've got 12 new groups across the world this year, with 172 groups across the globe, and that's an awful lot of members. Strictly speaking, in the UK, Dublin, of course, not being in the UK, but everyone else, this is where we are all located. And hopefully we should have input from Bristol, Southampton, and Edinburgh tonight. If you've got any announcements, if you're looking for a job or you're trying to hire someone for your job, pop into the PyData UK Slack into the jobs channel, just give a shout out in there. Similarly, if you organize a meetup or anything data related, get in there or tweet us on at PyData MCR on the hashtag PyDataUK hashtag, and yeah, someone will notice. If you want to get involved with any of your local PyData chapters or PyData UK, whether it's speaking as a guest, as a sponsor, a venue, when we're back allowed having physical venues, get in touch. Again, PyData MCR, but any of the PyData chapters will be glad to get involved. So tonight, our main panelists are going to be Paige Bailey from Google AI, although she is dealing with some internet issues in California. So fingers crossed she can get those sorted soon. And we've got Ozsvald from MOR Consulting and also PyData London. Before that, we've got three different speakers from, as I mentioned, PyData Edinburgh, PyData Southampton, and PyData Bristol, who'll be doing quick lightning talks, introducing themselves, their PyData meetup, and maybe some other stuff as well. None of this would be possible without known focus, and by none of this I mean the entire PyData stack, not just the PyData meetups, your Pandas, you know, all the open source repos that they help to develop and contribute to, and support the open source developers who write the things. Again, unfortunately, we can't go to the pub, but we will be in Slack to have a chat afterwards. So without further ado, if you bear with us one moment, we'll go over to Sam in Edinburgh.
Good evening from Edinburgh. I feel like it's the Eurovision Song Contest or something, and I'm supposed to align my scores or something for what's happened. Now, I can't share at the moment because you're sharing your screen, so it won't allow me. So if somebody could let me do that.
Yes, sorry.
No, that's absolutely fine. A small piece of technical wizardry. We can make this happen. As you say, we all work in tech.
I think I've unshared my screen.
I think that should allow me. So hopefully you can see some slides now. So a whistle-stop tour on PyData Edinburgh, just in case you weren't paying attention to the last few slides that came up. Edinburgh is currently the most northerly of our PyData groups in the UK. I'm going to criticise Meetup slightly just now because that little red dot is not where Edinburgh is. So follow the point of the label, and that's where Edinburgh is based. And we have 1,232 members at the moment. This is Edinburgh. So many of you might have been there. That's Tango Man, who sits on my desk in my office. I jokingly said at the end of this little intro, I wanted everyone to go away knowing where Edinburgh was, knowing who ran the PyData group in Edinburgh, and knowing that Scotland generally is very sunny, which is not what everyone expects. There's a wonderful bot on Twitter, if you like that sort of thing, that's based out of a big tech hub that's on the other side of Edinburgh Castle, so right on the other side of this picture. It's called Castle Rockbot, and you get a regular update as to whether or not it's raining or it's sunny, and a little picture of Edinburgh Castle to go with that. Edinburgh is an amazing place for the tech community. We have over 100 tech meetups that meet every month. So PyData Edinburgh is one of those groups. Every month we sell out our 100 tickets. We have a number of sponsors that are on the bottom of my slides who help support us run those groups, and we go to their different offices and they provide us with pizzas and drinks and things. The tech community is very open to new ideas and keen to share their own experiences and keen to hear other people's experiences. And as a group, PyData is very keen on encouraging people who perhaps aren't as experienced as speaking as some of them and have problems to share. That's something we love to hear about. What's not working for you? How do you get some additional help? I find the PyData community really good for offering up ideas, offering to help someone. More senior people will try and help more junior people to either get a new job, which definitely happened at the PyData groups, or just to learn some new things about Python. So who are we? So I'm Sam, I'm head of data at a company called Affini. And I'm got my two co-organizers here, Martina, who I believe might be out there watching this at the moment, and Nick as well. So the three of us have known each other for quite some time. And we heard that EuroPython was coming to Edinburgh in 2018. At that point, we were really pleased and thought, brilliant, we hope there's a data track in there. Wouldn't it be great if Edinburgh had a PyData to kind of coincide with that? And so we looked around the room and we realized that meant we were going to have to start PyData in Edinburgh. And so we did start PyData. So that was back in December 2017. As anyone who runs a group like this knows, it takes a little while to get it off the kind of starting block. So it took us till February 2018 before we ran our first event. We then immediately had something cancelled due to unprecedented world events, except it really was only Edinburgh. We had the most incredible snow blizzards, and that cancelled our second PyData. So we didn't quite get off to a great start, but we managed to press on from that. EuroPython came to Edinburgh, and we ran some events with EuroPython. Some of those were networking events. Some of those were about encouraging women in coming along to some of the events. I also run an organisation called Girl Geek Scotland, which supports women in tech. I would really encourage anyone to get involved with some of the conferences that come to your cities. Ask people to come and speak at your events. We've had some really good speakers come and talk for us who we might not normally have opportunity to. So, think out of the box about how you might find speakers to come along to your events. We've had new people join the organisation team at points. It's changed. We celebrated our first birthday in Lederhosen. We have a vast range of nationalities who come along to our events. So that's two of our organisers. Thomas is Austrian, so this was his traditional dress. So all sorts of costumes welcomed at PyData. We've had some interesting talks, and some of them have had a little bit of an unofficial competition for most interesting props. We've had a wonderful talk about prosthetic limbs and how AI can help improve the functionality of those. And we had a wonderful talk pre-Christmas about a competition to see who can fly a model aircraft the highest, and it's a wonderful thing that's got lots of information online if you want to know more about it. That man is clutching a drone, though it's quite hard to see, and there's a model aircraft at the back. We've lost people in the organisation team. We've sent out group questionnaires very recently, which included requests to get people to volunteer to help in the group. So as John's slide said earlier, offer up your services, get involved with any of these things and help make these groups happen. Our first virtual event is tomorrow night. So if you do want to join us, you are more than welcome. And after that, it's going to be Tuesday the 19th. So we're running them every 2 weeks. We're always interested in people that want to talk for us. And right now doing it virtually gives us a lot more opportunity. So please do get in touch with us. You can find us at various places. I think maybe these slides will get shared. We do have a GitHub repository into which we tend to put our slides. So we're certainly happy to make these slides available. And otherwise you can find us on Meetup. And that is PyData Edinburgh.
Thank you very much, Sam. Next up, we've got Adam Hill from Southampton. And yes, to your point, Sam, we will be making sure we can share anything we can do, either on GitHub or Drive or whatever the appropriate thing is. We're all about that open source. So yeah, Adam from Southampton.
Can you see my slide deck?
Oh, hey, we're having some audio issues there.
Yeah, no, I got confused as to which screen I was in.
No worries, we've all been there.
Yeah, can you see my slide deck at the moment?
Yes, we can.
Yeah, cool. Okay. So yes, thank you. My name's Adam Hill. I'm one of the co-organisers of PyData Southampton. And I will explain shortly why we are the Schrodinger's cat of PyData chapters. Following on from Sam's lovely presentation about Edinburgh, she'll be happy to know that I've corrected meetups for locating the different meetup chapters across the UK. And we are now the most southerly, so the opposite end of the country. If you're looking for us, we're at the peak of the south coast, all the way down there. If you want a better view, there you go. We're just, the Isle of Wight is just off the coast. We have the Forest of Dean, not the Forest of Dean, the New Forest off to the west of us, Portsmouth off to the east. And if you really want to see the zoom in, there's the city map. And the red dot there is approximately where our meetup venue would be if we were actually meeting. On here, you can see some of the co-organisers for whom I could find digital photographs for. Sam, Thomas, Jakob, and Robin. We have a few others. And this neatly kind of brings me back to why I called us the Schrodinger's cat of PyData chapters. We are brand new. So much so, our first launch meetup event was supposed to happen about 2 weeks ago. And unsurprisingly, we had to cancel it. So we were meant to be launching on April the 16th. We've been planning and working in the preceding months, trying to get everything sorted out, trying to find a funder, trying to find a venue, figuring out how we were going to do this, who was going to actually help out doing all of this stuff. And it's great that I managed to band a few people together. But unfortunately, world events overtook us. So back in, I think towards pretty much at the beginning of March, we saw what was coming ahead of us and cancelled because we didn't think it was going to work. We weren't actually planning on doing any virtual events, mainly because we hadn't built a community yet. So it's fantastic that PyData UK has come together because we can latch on a little bit on that and hopefully grow our community. Interestingly, I checked in today, our meetups group currently has 61 members. So we've got 61 people ready and raring to go once we can get back to the practice of meeting. And I'm really enthusiastic for meeting the local community and really getting involved. I'm a long-time fan, personally, of PyData. Part of the reason why I proposed to a few of these other gluttons for punishment to form Southampton was I've been involved with PyData London, attending their events, going to the annual conference for multiple years now, and have seen what a fantastic and engaging community it is, and really like it. So I thought, what can we do in Southampton? Now the question is, why Southampton? And this is part of the reason why. There are two large universities, if you're not familiar with Southampton here. So you've got the University of Southampton and Southampton Solent University. Starling Bank just opened one of their offices here in the last year or so. And if you're not aware of them, they're one of the new modern fintech banks, and they're pushing and trying to build a community. Equally, there's Ordnance Survey and the Office for National Statistics, who I've been engaged with in the past on charitable data science projects. And Tech Solent is being born out of a combination of the university community, Southampton City Council, and a few other local companies trying to see if they can build a tech hub effectively on the south coast of the UK. Snowflake Software has supported me in some of the charity activities. We had a DataKind meetup here in Southampton the other year, if you're aware of DataKind. And IBM are one of the big local companies, as are Carnival Cruises. So what we see is that there's a lot of tech coming to the south coast. There's a lot of encouragement for it to continue and to grow. So we think we've got quite a dynamic group here, and we're hoping that this is going to turn into a really rich community. Ametria, I should actually mention, they are currently on the hook for being our sponsor once we get going. They're very much about data. They're very much about Python, so that it was a natural fit. Hopefully, they will make it through this current crisis and still be offering to cover our meetup bills, as it were. But I will bring you back to our main piece. As we are so new, we don't currently have a Twitter handle because I haven't got anyone to be responsible yet for tweeting anything. And so if you want to get in touch with us, you can find us on meetup.com. There's the link. If you're either on the South Coast or you're planning on visiting the South Coast, you want to give a talk at some point in the future when we can go live again, please get in touch. We'd be happy to have you. Like I say, we're trying to build something new, and hopefully it'll all turn to a success, and maybe we'll see you in the future.
Thanks a lot, Adam. Yeah, it's fantastic. It's way more about the Southampton tech environment than I ever expected to know before we started organising this. It's fantastic. Next up, we've got John Sandel from one of the organisers of PyData Bristol.
Okay, hello.
Hey, John.
Can you see my screen?
Certainly can.
Wonderful stuff. Okay, so we started PyData Bristol just over 2.5 years ago, February 2018, and it's been a wild and wonderful ride, sort of taking PyData into the west of England since then. So I'm sort of representing a brilliant team that we've sort of put together over the last couple of years. So thank you, massive thanks for everything they've done to Mikkel, Frank, David, James, Lenka, and Bharat for making this run. And for those of you who are just starting your own chapter, it is a beautiful day when all of your initial organizers can't make an event for various reasons, such as sort of new children and new projects and jobs coming along. And yet the new people who have just come onto a committee can just run one of these events and just take the strain. And that's a really, really amazing thing to have experienced over the last few months this year. Thank you also to NumFocus and Coefficient and Ovo Energy, who have been our main venue hosts, and also for the entirety of 2019 we had IBM sponsoring us, providing our pizza and drinks. So Bristol itself has a really interesting history in terms of especially ships and engineering. Engineering heritage reigns strong in Bristol to this day, and so there's a really amazing dynamic community which fuses both the academic heritage in the universities in Bristol and Bath, and also you've got Cardiff very, very nearby. And so speaking of Cardiff, you also have this PyData Bristol and PyData Cardiff launched almost in the same month. And for the first year of operation, we just acted as sister meetups, alternating every single month with people from Bristol attending Cardiff and vice versa. And we still have that dynamic today. So sort of hugely supportive of each other's cities and sort of within striking distance of each other too. The event format we run is sort of very similar to our inspiration, which is PyData London. Some lightnings, some talks, focus on the pizza is always important. The pizza options, a very hot topic of feedback, and the networking, of course, because the idea at the end of the day is to create a community which is run by that community for itself. So the networking is a core part of what we do, inviting people to come and give talks, inviting those who've never spoken in a meetup before to come and give a lightning talk is an easy way into it, and then perhaps one of the longer talks after that. We have a friendly rivalry with Cardiff, so we use some Seaborn style charts, or it might be Matplotlib with the XKCD theme going on, to track exactly how we're doing against Cardiff, and we've never really caught up on our numbers, and Cardiff are a little bit out of date, but we're going to get there. We're gonna catch up Cardiff one of these days. But at the moment, we're roughly hitting 908 members. We've run now 15 full meetups over the last 2.5 years. And what we started doing, first of all, you can see all of our meetups, but also all of our slides for all of our meetups. And some of these have been videoed as well. All of that is on our GitHub, so PyData Bristol /meetups. And as you can see, it's Mikkel putting in the amazing hours to make this all available for anybody who wants to see this content. But we also run a lot of workshops. So for a lot of our meetups, we've run a pre-meetup workshop, sometimes a short workshop, sometimes much longer. And we, just before the current situation landed on us, we initialized a new program of what was designed to be one workshop every month, sort of a zero to hero program. And we're looking into how we can make that run virtually. But at least we have a program, because what we want to do is not just build the community within those who are sort of already understand Python and Pandas and the PyData stack, but also to bring new people into the community by running workshops designed for people with zero, potentially programming knowledge at all whatsoever. And that's what we managed to achieve, at least in January and February. And we look forward to resuming that when we can. And on that theme, we will be launching next week. We have our first new online masterclass. So the idea here is to find people who are really excellent at what they do, and then work with them in a very sort of Pythonic style. So we'll be launching masterclass, will be running next Thursday, featuring Ben Sparks from Bath University, and also you can see him on the Numberphile coronavirus video, which is around about 800,000 views on YouTube. And we're really exciting to showcase both best-in-class communicators alongside best-in-class sort of Python side by side in a single, what we're showcasing as a masterclass. So if you want to learn more about PyData Bristol, you can follow us on PyData Bristol on Twitter. And there's lots of news around things that you can sign up to, and also tips and tricks from what we're learning. Which segues into, John gave me the opportunity to do a 5-minute lightning talk. So lightnings are the core, I think, of or one of the PyData traditions, the overly opportunistic lightning talk. And I just want to try and do, in 5 minutes, a Python productivity power-ups. This is 5 packages for 5 minutes. So these are 5 of the packages which I have, I think, mostly discovered or started using in the last 12 months. And I've found amazing. I wish I knew about them sooner. So without further ado, package number 1. TQDM, I think the author of this, based in London and also in the London PyData community. And I may have uninstalled TQDM in the course of getting this onto GitHub. So what does it do? Simply, instead of doing for something in something and waiting and wondering when is this going to be done, just wrap it in this TQDM function, and it will print out a progress bar. It is simply that. There's a few nice tricks, and you can see more of these in the repo. But I'm just showing you the core functionality and a few things that you might want to know about. The thing that I really love about this, I discovered very recently, was the fact that they have a TQDM Pandas option. And furthermore, you can use that to, instead of just doing df.apply, you can do df.progressApply to stick a progress bar around any apply call that you have. So I've got a fairly short one going on here, but it's a really, really useful tip. You've got something that might take a few minutes or a few hours, and you want to know, do I have time to go and get a cup of tea? That's what it's for. Or if you just need a quick talk timer. I'm not going to run that, otherwise it might take 4 minutes, and I only have 4 minutes left to finish this talk. So the next up, Black. Black, if you haven't come across it before, is an auto formatter for Python. So I'm not just demonstrating black here, I'm demonstrating the notebook black package. And what that means is it applies black within the context of a Jupyter notebook. So it takes something like this, or maybe you haven't quite got your PEP8 compliant Python code. Fear not, because it will do it for you. So auto formatting all of your code. You don't need to worry about whether you've got your spaces in the right place anymore. Just run the cell and it will reformat to entirely PEP8 compliant code. It's a really beautiful library. It saves you a lot of time, and you'll find if you're not using black at the moment, and if you can stomach black's recommendations, because it's very, very opinionated, but becoming increasingly popular, it's really, really nice just to work with. Suddenly all of this goes away, something to worry about, and everyone's writing code just like you write code. Next up, iSort. So I'm going to actually throw across to Visual Studio Code here to explain what iSort does. Black is for formatting your code, but iSort is for formatting into a PEP8 compliant manner your imports. So iSort is semi-built into VS Code, and you can also install it and you can apply it manually. But I'm just going to demonstrate the idea of running iSort in VS Code here. This is within the repo that is online at the moment. Just hit save, iSort gets applied, and all of the imports are then cleaned up into a PEP8 compliant library. I've then got all of my linters highlighting how this is all completely pointless. But for just going from here to, I just hit save and iSort applies that in place, is really, really nice. Again, you don't need to worry about whether your libraries are imported in the right order in terms of first party, third party, and so on. Next up, Loggeroo. Do you print lots of things in your code? Do you spend ages configuring loggers so that you can run them on servers and have that go into a logging setup? I think this has been a really nice discovery from just literally the last month for me. Just switch out all of your print statements to Loggeroo statements, and it will auto configure a really nice logging tool. So just as almost a replacement for the Python logger. But what does that mean when you're actually working with Loggeroo in a notebook, something like this? Then it means that it also prints out beautifully formatted as well. So color-coded, nicely calibrated, nicely designed log messages. The final little tip and trick is joblib. And joblib is a huge library, and you're going to learn far more from Ian's book about how best to use joblib. But there's one thing in joblib that I discovered in the last month that has been awesome for me, because I've rewritten this functionality so many times myself. And this is the little caching of functions. So first of all, this is not PEP8 compliant code, but now that I have Notebook Black installed, it will auto format for me. So what is joblib doing here? I'm only using the memory function from this, or the class. I'm specifying a directory where joblib will cache things. And then at the moment, I have a function. All it does is it takes an input, it returns that input multiplied by 10, but takes a while doing it by sleeping for 3 seconds. If I add this Python decorator, and if you're not sure, if you haven't used Python decorators before, just use this code. It's on GitHub. It's a really good starting point just to apply this functionality. And what is the functionality that I want? Sometimes you have a slow function, say like an API call. It takes a while. In this case, it's taking 3 seconds. And sometimes you want to say, look, I don't want to have to, it might be something like a web scraper. I don't want to have to re-scrape the same page over and over again, just because I'm rerunning my function. I haven't cached the result or saved it somewhere. What this memory.cache does, so it means if you run exactly the same function again with exactly the same inputs, and you can have multiple inputs in this, it will just return the cached version. So you have a slow version when it runs it for the first time, and a fast when it runs it for the second time. And if I try another input here, it will take a few seconds, but the second time I run this, it's immediate because it's being returned from the local cache. So if you want to see any of that, that is on GitHub, all of this notebook, all of this code, and I will be tweeting that out, and we'll be sharing all of this as well via Slack and so on. So thank you very much. And that is 5 Python packages to power up your productivity.
Thanks, John. That's fantastic. Yeah, a bunch of really useful hacks and tricks there. We'll be sure to make sure we share your links afterwards, so everyone else can make best use of them. We're going to take a 2-minute break now for people to visit the bathroom, help yourself to the pizza that I'm sure you've all got at home, and then we'll be back with Paige Bailey from Google AI.
Awesome. Hello, everyone. My name is Paige Bailey, and I'm here from Google AI to tell you a little bit about TensorFlow Probability. I'm a product manager, though historically I've been more of a machine learning engineer and a developer advocate. And even though I'm celebrating the great work that's being done by the TF Probability team, known internally as the Bayesflow team, this is really just one project in an entire ecosystem that we work on as part of TensorFlow. So if you haven't had a chance to take a look at all of our projects, there are a ton at github.com/TensorFlow. And I think the last count, we had something like 90 that were being worked on internally. And then of course, a ton of really great projects that are being run by the external community. So I'm dynamic web page pretty much everywhere on the internet, GitHub, Twitter, etc. If you have any questions later on and you want to have a jam session about TensorFlow, always feel free to reach out. I'm also dynamic web page or just web page at google.com. So with that, let's get started. So today I'm here to talk to you about probabilistic programming in TensorFlow, and specifically through something called TensorFlow Probability, though this is one of many packages that allow you to do probabilistic deep learning. And so for starters, we're going to dive right into an example. So suppose you want to predict these blue dots that you see here on the screen. And that is the y coordinate based on the x coordinate. And Keras makes this problem really, really easy. Keras, if you don't have familiarity with it, it's a high-level API on top of TensorFlow. Historically, Keras was a standalone library that you had to pip install separately. And now it's actually baked into the TensorFlow API as tf.keras. We've added a whole bunch of performance benefits. So it allows you to do things like distributed computation, both across a single node and across multiple nodes simultaneously. But the TLDR is that Keras makes it super easy to do deep learning on top of TensorFlow. But as you can see here, we've set up a dense neural network with one hidden layer, and it outputs a single float, which is that y coordinate. We've also chosen a mean squared error loss, which is a pretty decent default choice. But if we want to understand which loss function is the best, how would we know? And here you can see the loss function that we've selected is mean squared error. But there are really a variety of choices that you could have here. And choosing the right loss function is tough. And improving a reasonable one, well, that can be even tougher. And once you fit your model, it's really difficult to understand if it's good and if your accuracy tells you the full picture. And also, what about the mean and the variance and all of those other great statistics terms that you probably remember from university, right? So wouldn't it be great if there existed some way of simply maximizing the log likelihood? And even better, wouldn't it be nice to get back a distribution object for which we'd already had readily available summary statistics, like mean and variance and entropy and mode. So if you've ever played with rstats and a whole bunch of their statistics packages, you probably have been joyful that all of those metrics are included out of the box for you with pretty much any API call you make. So in short, wouldn't it be great if we had exactly what you see on the slide here? And guess what? You can by using a distribution layer instead. So here you see tfp.layers.distribution lambda. You can encode a mean squared error loss via that normal distribution. And although it's an equivalent formulation, this now means that you can use a generic loss maximum likelihood. And furthermore, since that last layer is a distribution, when you query a model, you get a distribution object and all of its summary statistics. So not just a tensor. And this is really beautiful because as we all know, as you're making predictions, it's usually not just one value, it's an entire spectrum of possibilities that could come back to you. So neat, right? And but something seems a little bit fishy, because I wonder, if the response variable, the one that we've observed here, really has a constant variance. Like just looking at these blue dots on the screen, it doesn't look like they're all following, the exact same trend, right? Like there's a whole bunch of skew off as you get to larger numbers on the x-axis. And so if you change this one line, you learn that your observations vary, that there's uncertainty, that it's that you have heteroscedasticity. And these known unknowns, there's something that we can measure. So by thinking probabilistically, it's pretty obvious where our model is deficient. It lacks like this little lever to understand variance. And this kind of uncertainty is sometimes called aleatoric uncertainty or heteroscedasticity. I can never say that right. But there's also a really great, if you like music, there's a great song by the Books that uses aleatoric in a really interesting way. That was a tangent. So that's a neat trick. We just changed one line and we suddenly got all of this information. But there's a lot of data here, right? So can we just trust these predictions that we're making? And the answer is maybe. Right? And so notice that we swap out the old Keras dense layers with these new like dense variational layers, but it still looks pretty much exactly the same. And these layers treat the kernel and bias as random variables for whom our belief in their value formally increases with more evidence, right? So the more data you get, the more information you have, and the better assumptions you can make. And this formalization is the Bayesian approach. And so you could call these Bayesian weights. And more precisely, this is like learning an infinitely large ensemble of models all at once. And the graph here depicts some random draws from the weights distribution. And this flavor of uncertainty is sometimes called epistemic uncertainty. And it's definitely progress. But the observations, what about these unknown or known unknowns, right? Like these things that we don't know that we don't know. Did we lose that modeling capability? And we didn't, because these are all layers. And because Keras is a modular framework for function composition, we can do all of these things in one go. We're able to account for both epistemic and aleatoric uncertainty. And to recap, notice that our weights are Bayesian, meaning we're tracking infinitely many models. We're learning the variance present in the data itself. And that linear regression here means maximum likely normal distribution. So this is great. And if you had experience using machine learning, like all of this should look pretty straightforward, even if you've had the most basic kind of like 101 class, right? Like it's all sort of fancy flavors on top of linear regression. And I love it. So how do I even know though if I'm fitting a line is right? Right, like if I mean, this is 2020, right? Like, should we really just be trying to fit lines still? And it turns out that this data wasn't linear to begin with. It was sinusoidal. You can see all of these beautiful sort of sinusoidal patterns as you trend out on the x-axis. And so how did we accomplish this feat? Well, it's a Gaussian process, right? And a Gaussian process is a distribution over functions, a line being one of those potential functions. And it sounds complicated, even for a computer. And sometimes it is. But when you condition on observations, it's just another kind of normal distribution. And again, the really cool thing is that TFP gives you all of this out of the box. And by changing just one line on these slides, we kind of systematically explored modeling assumptions. And we fit those models uniformly via minimizing negative log likelihood. And we only used this sort of very well-established Keras workflow. We're able to mix and match TFP layers with Keras in a very straightforward way. And so how could this be so easy, right? Like, what is the trick? And it's actually TFP, so TensorFlow Probability, which is a toolbox for probabilistic modeling. And it's great for both statisticians and sort of more traditional data scientists, as well as machine learning researchers and practitioners. Like if you look at, for example, the NeurIPS papers from last year, NeurIPS is a sort of famous conference for deep learning. It has kind of all the usual suspects always showing up. TensorFlow probability was used quite heavily in many of the papers for that conference. So while all of these Keras examples that I've just shown you are pretty cool, that's just one small part of the TensorFlow probability toolbox. So there are tools for building the models, such as distributions, bijectors, layers and losses, joint distributions, as well as tools for doing inference, Markov chain Monte Carlo or MCMC, variational inference, optimizers, lots and lots of great things for you to use just kind of out of the box. And broadly speaking, TFP offers tools to help specify probabilistic models and then make inference under those models. So if we wanted to do kind of a deep dive on distributions, to customize your model, you would use TFP to build exactly the model you want with low-level primitives. And then you would choose a powerful, scalable inference technique, whichever happens to be ideal for your model. As I mentioned before, distributions are the growing kind of sizable collection of probability distributions. You also have things like bijectors. I think right now there are 22 composable transformations available for these distributions. You have layers, which are essentially neural network layers with uncertainty over their output, and losses, which make it easier to write a loss function. So for example, Monte Carlo expectations, scores, tricks, or score tricks, etc. And then there's also Edward 2, which is a recently announced PPL built on top of TFP. For inference, you have MCMC, which approximates integrals via sampling. So in other words, you can sample from the posterior since computing P of X directly is NP hard. And that includes Hamiltonian, Monte Carlo, and Metropolis Hastings. You can also do variational inference. So you can compute the posterior by computing probability of a similar distribution, and optimizers, so stochastic optimization methods. So if you wanted to dive a little bit deeper, we could take a look at the methods for a TFP distribution. And distribution is a Python class which encodes some useful properties of a random variable. So you can see sampling, which allows you to draw a sample from a distribution, which is useful for Monte Carlo approximations. Evaluate, which has things like prob and the cumulative density function, and survival. Summarize, which is basic summary stats for distribution. So similar to those beautiful R-stats things that I was mentioning before. Compare, which allows you to sort of understand entropy and cross entropy. Vectorize, and more. And if you wanted to see an example of using the distributions class, this is kind of the hello world of distributions, where you create a distribution, you sample from it, you compute the probability of the sample, and it's powerful enough, even though it is quite simple, to encode very rich ideas. So there are a number of collab examples that are available online for you to take a look at. And just to make sure that I have enough time to get to the demo, I'm going to blast through these, but we'll look at the collab example a little bit later in the presentation. So that's a batch of Gaussian distributions, I believe. Yep. And then categorical distributions. And again, you're able to encode all of this directly into TFP. And the result would be a distribution instance, which you can use to generate samples, compute log probabilities, etc. Cool. And that's the sort of the same general concepts, but a little bit fancier of a result, right? So Gaussian processes are super ubiquitous in applied statistics, and they're as straightforward as an API call. I should also probably say that distributions are tf.modules. And you'll also see a couple of sort of interesting artifacts here from TensorFlow 2. So I'm not sure, based on the background of folks on the call, if you've had experience doing deep learning in general, or deep learning with a specific kind of framework. TF modules have a very similar syntax to PyTorch's .nn module. And gradient tape is kind of the way that you would do gradients within TensorFlow 2. So it essentially just tracks gradients as you build your computation graphs. TF modules are really, really powerful. I strongly suggest you take a look at them. And they also allow you to get very, very low level and tight control of all of these abstractions that you're building. So you can think of distributions as an object-oriented and declarative way to write models. And models can encapsulate two computations, drawing random samples and computing densities and probabilities. And that means that no computation happens when we construct a distribution. We're defining a sample and a log prob computation, also CDF, to run later. And we can use tf.convert to tensor, numbers, lists, etc., but not variables. And that's like variables with a capital V. And just noting, if you drew samples, you could take gradients through the samples using a reparameterization trick. So if a user writes this instead, so let me just bounce back. Yep, it won't work because tf.exp reads the value of a log scale and does the exponentiation before you build the model. So when you compute the log probability under the gradient tape, you don't see or use the log scale variable, and log scale won't be in this D trainable variables thing. So that's just kind of like a gotcha if you are kind of working with the distributions. And that's just pointing out that there would be that it wouldn't quite work. So in TensorFlow 2, deferred tensor acts like a tensor. It has a dot shape and a dot D type, but the computation it wraps isn't run until some operation actually tries to read or use the value of the deferred tensor. And it's also a module, so both variables show up in the trainable variables below. So that was kind of a very high-level view of TensorFlow probability towards the beginning, and then like a more low-level view if you wanted to use it for your academic research or for highly complex workloads. At Google, I know that we use it a ton on TPUs and at very, very large scale, especially with some of our teams that have to deal with sort of lots and lots of data. But these next slides are just kind of showing how much presence TFP has in the broader Python ecosystem. So here you can see adoption. This is from PipInfo. And we had about 200,000 pip installs last month, which is pretty cool. There was also a big spiky just recently, so maybe folks are getting bored as we're all, you know, COVIDing away in our apartments or in our houses. It supports both TensorFlow 2 and Keras, as well as JAX. Like the JAX backend was just recently added. It's used by PyMC4, companies like Baker Hughes for some of their, I think, their turbine and sort of mechanical engineering detection if products are about to break situation. And as I mentioned before, a substantial fraction of NeurIPS papers using TensorFlow also used TensorFlow Probability. And I haven't done an analysis of other conferences like ICML or CBPR or whatever, but I'm sure that TFP is also being pretty heavily used there. It's also performant, so which isn't, you know, like which isn't often something that you could say about some other potential packages, right? But TFP computation graphs are often quite large with loops and other dynamic control flow. Lots of CPU ops stitched together, which speaks to that last bullet point about caring about CPU performance. Right now, we're working on a project called MLIR, which helps to stitch together a lot of those CPU computations into something that the compiler can understand and optimize. You can operate on relatively smaller data, generate many random numbers, use esoteric math ops, and we also depend very, very heavily on something called XLA for performance. XLA is a compiler technology that is, it is essentially the way that TPUs work right now. And it allows for very, very efficient matrix computations on this highly specialized hardware. So if you haven't taken a look at XLA, it's pretty nifty. MLIR, also very nifty, if you're into compilers. And there's also much, much more, right? So sequential Monte Carlo, variational inference, generalized linear models, Bayesian neural networks, variational autoencoders, structural time series, epidemiology. The list goes on and on and on. There's also really, really cool environmental work being done with TensorFlow Probability. And if you would like to learn more, there are a lot of ways to get involved. So there's the tensorflow.org/probability website, tfprobability@tensorflow.org as a mailing list. And we also have github.com/tensorflow/probability. The take-home message is that you can express your domain knowledge as a probabilistic model, and you can use TFP to execute it. And then this is just kind of a success story of BHGE doing anomaly detection in industrial systems. So you can kind of understand that it's viable for business use cases and not just this crazy academic hoo-ha. You can so they had a 50% reduction in false positives, 300% reduction in false negatives, because again their data doesn't really fit into that nice sort of single value answer for a distribution. And you've also had a 10x improvement in model training and performance over random search. So try it out. I guess that's the final takeaway. Bayesian methods for hackers has been upgraded to include TFP as part of its latest edition. You can pip install it just as you would pip install anything. And you can learn and discuss more at tfprobability@tensorflow.org, as well as tensorflow.org/probability. And that looks like That looks like about time. So what I am going to do is I am going to, in my last couple of minutes, I am going to try to do a demo, and hopefully the demo gods will agree with me. So let us go to here. Cool. So this is tensorflow.org/probability. Hopefully everybody can see my screen. What you see here is kind of a revamped version of the TensorFlow website. We recently gave it kind of a facelift as part of our upgrade to TensorFlow 2, and there are a whole bunch of things that you can use here to learn, to understand APIs, to understand how to use and extend models and libraries, and to also interact with the broader TensorFlow community. But this is the tensorflow.org landing page. You can see here a very simplistic example off to the right, as well as a whole bunch of examples of real-world use cases for TensorFlow probability on our TensorFlow blog. We also have a link to the GitHub repo in this lower right-hand corner. But if we want to try a guide or tutorial, what I would like to point out specifically is if you see here, there's a little button saying run in a Colab notebook. I'm not sure how many of you folks have tried out Colab, but I strongly recommend it. And when you click on that little button, you see something that looks very familiar. Hopefully, it looks like a Jupyter notebook. And what this allows you to do is run code for free online. So you can you probably recognize the sort of options up the top, right? So you can see the runtime tab. You can select run all, and it starts cycling through each one of the cells and running all of the examples. And then you can also change your runtime type. So if you want to try out a different hardware accelerator, you can select a GPU or even a TPU, and hopefully it works. Cool. So it looks like we have an error, and that's because this notebook no longer you no longer need eager execution as part of TensorFlow 2. You can see here we're running TF 2.2, and hopefully this works. Yes, and that was very fast. So you can see here that we have we've created a normal distribution, and we've also specified a model. Here is the Bernoulli. You can also see that there are little helpful code hints as you hover over specific values in the Colab, and we fit a model given this data and printed the coefficients. And all in all, it took very little time. If we go back to tensorflow.org/probability, so let me do that. You can see here that there's a little tab that says guides and tutorials. And when you click on this guy, there's a whole bunch of documentation. You can click on, for example, the 8 schools problem, and it takes you to a Jupyter notebook housed on our GitHub page. You can also select Run in Google Colab from here, and it will take you to exactly what you saw before. The only trick is that you would probably also have to comment out this TF enable v2 behavior, because now with TensorFlow 2, everything's eager by default, which means you type in something, you get back an answer immediately, and it feels very Pythonic, like scikit-learn. Historically, TensorFlow had this like really wonky behavior where you would have to like create sessions and have feed dicts and like try to write Python the way that a distributed systems engineer would be attempting to write Python. But now with TensorFlow 2, everything is much more straightforward. It aligns much more with the Python and PyData scientific computing ecosystem. So you can just use NumPy arrays. There are integrations with Pandas and with sort of scikit-learn. So for example, Keras Tuner, even though it has Keras in the title, you can use it for hyperparameter tuning on scikit-learn models. And even I believe TFX is thinking about supporting things like XGBoost and scikit-learn. So that is my shtick. Hopefully it was useful. Thank you for having me. I'm really excited to see such a large scale event happening for all of these PyData communities across England and across Europe in general. And yes, if you have any questions, always feel free to contact me. I'm happy to answer and happy to help any kind I can.
Cool, fantastic. Thank you very much, Paige.
Thank you.
That was great. Have you got time to answer a couple of questions now?
Sure, absolutely. And then I do have to run to a meeting that I'm a tad bit late for, but this is great.
We'll keep it to just the one then, because I realize it's the middle of your workday.
Cool.
So there's been a couple of questions in the chat, and you did mention it yourself about PyMC3.
Yeah.
It seems very similar, but also distinct. What's the benefits? What's the distinction?
Right. So TensorFlow Probability supports autodiff, and I think I mentioned it before in one of the final slides. PyMC4 actually uses TFP as a backend. So I think they're both great products. But TensorFlow Probability is really intended to be specifically for these deep learning use cases, and also to give people the ability to unlock accelerators. So if you're using TFP, you can also use GPUs or clusters of GPUs, as well as TPUs, and via this kind of standard TensorFlow distribution strategies. So those are that I would say is the kicker. It's also really interesting in that many of the sort of commonly used Python packages don't work nicely with deep learning frameworks because they don't support autodiff, and all of the computation is happening on the CPU. So like you get these really awkward like data copying situations that kind of eat up your memory, or you end up with these really frustrating slowdowns. And sort of TFP allows you to do probabilistic programming simultaneously with tools like TensorFlow or JAX without having to experience those slowdowns.
Cool. That sounds like a massive upgrade already.
Yep.
Cool.
Cool beans.
Thank you very much for joining us, Paige, and thank you for putting in all the effort to overcome the internet issues. Really appreciate it.
Thank you so much. Have a great day.
Thanks, you too. Next up in a moment, we're going to have Ian Ozsvald of PyData London, who's going to be speaking about how to get the most and work more efficiently with high volumes of data in Pandas, and ways of approaching that. welcome back. So next up, we've got Ian from PyData London. Go ahead, Ian.
Thank you very much, John. So hello, everyone. My name is Ian Ozsvald. I'm one of the co-founders of PyData London. So it's really nice to be here, first of all. I'm really glad that we've got PyData UK working. I gently suggested the idea a month ago to the PyData Manchester team, and they ran with it, which is brilliant, because now we have a whole new 11th meetup experience running in the UK. I was super happy when we got the second meetup running in the UK after PyData London. Now there's 10 running across the UK, and we've got a bunch of representatives here. So I was going to say thanks to Sam, Adam, and John for being involved in the early introductions. I know that Ole is here from PyData Cambridge, and we might have representatives here from Lancaster and Cardiff and Cranfield as well. And I know some of my London colleagues are here. So that's brilliant. And now we've got PyData UK, and I hope a bunch of you are in the Slack channel, which is also hosted by PyData Manchester. And huge thanks to Paige as well for that great introduction to TensorFlow Probability, which is entirely new for me. So what am I talking about here? I'll be talking about making Pandas run faster, so handling more data on a single machine and making calculations go faster. Why do I care about this? Well, I'm an interim chief data scientist, so I go and help teams temporarily, often when they're lacking a senior hands-on data scientist. I've been doing this for decades, and along the way, I've spoken a lot about high-performance Python. On my slide on the right, I've written a book with O'Reilly and Misha Gorolik on high-performance Python. We wrote that 6 years ago. We've just finished the second edition. I'm super happy about this. We agreed last summer to spend one person month each working on the second edition, and after only 9 months and many person months worth of work, we finally finished the darn thing. I was told on Friday that it's actually gone to the printers. It went to the printers in time that we could have it ready to do some signings at the PyData London conference that would have been running in a couple of weeks' time. But it turns out, due to our global pandemic, we can't do that. So the physical copies will be available. They're already available in the early access program on O'Reilly. And I enjoy talking about how to enable us to crunch more data. I also run some public courses on this. I've got one coming up. Some of the slides that we've got here and that are on my blog from recent talks that I've done have come from some of the material from the course. So what is today's goal? So I'm going to give you some feedback from lots of years' experience based on some ways to make Pandas more performant. So we're going to have about 15-20 minutes on this. I've got a notebook to walk through. We're going to save RAM so that we can get more into our machine, and we're going to calculate faster in some cases by dropping down to NumPy and Number. And I will also briefly talk about another library called Modin, which can make our Pandas run even faster on a machine with enough RAM and a large enough problem. I've been looking at a particular data set from Companies House whilst I've been working on some of this. And so I'll end with a slide on what do we see from one view on economic activity in the UK as a result of our pandemic, to take this back slightly into the real world. Oh, we don't want that slide yet. We want my notebook. So I trust that you can all see my notebook. I'm just going to make this a bit bigger. So we're going to look at saving some RAM first of all, and then making things run a bit quicker. So here I've loaded in a pre-prepared data set. This is a download of 4.5 million companies' house entries for UK companies. It's UK companies that are active because dissolved companies get taken out of the data set. So this represents everything that's active, at least in the UK at the moment. So yeah, 4.5 million rows, and here I've pre-processed this data and taken out only some of the columns, so particularly company names, their numbers, the company status, and an incorporation date. So we've got a mix of data types. We've got strings. Company number is actually a string because it can be preceded by 0, and it can have things like RC if it's a Royal Charter company inside it. Company status is a string, and date. So we've got a nice mix of regular Pandas data types. So one thing that we might do is say, well, hey, we've got 4.5 million entries. What is the state of these entries? We want to count the company status, so we use a value counts. And we can see that the majority of the entries here are active companies. So we've got 4.2 million active companies, and then we've got a smaller number of companies that are proposed to strike off, some that are liquidated, some that are dissolved, and then when they're actually fully dissolved, they get taken out of this register, and then a bunch of minor counts after that. So it's relatively easy to count this all up. We do this in regular pandas on the string column. We call value counts 4.5 million rows. Here I'm using my IPython memory usage tool, which prints out this line at the bottom. So this gives us a little idea of the RAM that's used inside every operation that occurs in Jupyter or in the IPython shell, and how it changes the RAM envelope as well that's being used both in the background of an operation. So we can see that some operations take quite a lot of RAM, and they give us some timing information as well. But we can also ask for some more diagnostics from Pandas itself. So I can say to the data frame on the company status column, what is your memory usage? And it tells me that it's 73 megabytes. So that's quite a lot of RAM for something that has the word active repeated almost all of the time. So there's a lot of repetition going on in here because of these Pandas strings being repeated. So we have a trick that was introduced in the last 2 years in Pandas. We have the category data type. So we can turn the company status column, these strings, into a category. And then I've called it a new column, company status underscore cat. So we can differentiate these two and check the RAM usage. If I then do data frame company status cat value counts, I get exactly the same answer. So we can treat it as exactly the same thing. So this is brilliant. We now get, in this case, I'm using it as a read-only column, but we'll see that it's got much better performance characteristics. And it happens for free for us. We can just convert those strings into this category. And we can do the same conversion with numeric types. If you've got integers or ordinals where you have a small number of distinct items and many repetitions, turning them into a category is probably a good thing to do. So if I ask the company status cat column what its memory usage is, well, it's 41 megabytes, not the 70 odd megabytes that we had before. So it's almost cut in half just for converting it to a category type. So that's nice. That's great, right? We can now fit more rows into RAM if we use the category data type by a factor of about 2. So that's pretty cool. We can see behind the scenes. Some of you will know that, say, with date times, we have a .dt accessor in Pandas, and with strings, we have a .str accessor. For categories, we have a .cat accessor, and behind the .cat, we can get the categories. So we can see all of the unique categories that we have available. And then if I ask for the codes, we can see the integer codes that are held behind the scenes to map the string names that we had to the underlying numeric coding. And it's this numeric coding that gives us the speed up, because behind the scenes, whenever we do an operation like a value count, we're counting integers rather than counting strings, which are a more expensive operation. So if we do a time it, we use %timeit on the company status column to run the value counts operation. It takes 480 milliseconds, so it's reasonably fast, half a second, but it still takes a little while. And if we had many millions of rows, not just 4.5 million, that would take an appreciable amount of time. If we do a company status cat column and we do the value counts, it takes 37 milliseconds. So that's more than 10 times faster for almost no effort on your part. So it's more than 10 times faster for very little effort. And then it turns out we get some other benefits as well. So if we set the index on our data frame, so here I'm making a new data frame, surrogate data frame, which is a view upon the original, so no big memory copy. And we set the index with company status category, and I make a different one with no category, and so I'm just using the string-based company status column for that index. Then I can make masks. So I can then say, well, what if df2 cat.index compares to liquidation, the string liquidation? Well, how long does that take? Well, 848. And we do look at the same thing for the no category version, and it takes 270. And you might say, hang on a minute, 848 sounds like more than 270. But what we've been missing there, of course, is this has 848 microseconds as opposed to 270 milliseconds. So it's a 3 orders of magnitude speed difference, or several orders of magnitude speed difference going on there. So if we use the categories to represent our column when we want to do lots of querying, then it goes faster. So our value counts on a regular column goes faster. And if we set it onto an index, then any indexing operations will also go faster, and we use much less RAM. So if you've got large data sets and things run a bit slower than you would like, particularly if you're using strings, but the same thing does apply to using, say, integers for ordinal indexing. If you've got a small number of items repeated many times, do try out the category data type. Things should run faster. So now I'm going to make a new column. I want to calculate the age of my companies. So I'm going to take today's date time. I'm going to subtract it from the incorporation date of a company, and that will give me an age in days. I divide by 360, and I get a floating point representation of the age of a company using a float 64. So that's the default 8-byte representation in a column telling me how old a company is. And here I've drawn a diagram. I'm slightly embarrassed to admit here that I forgot to annotate this diagram. Some of you who know me and see me talk about this know that I get pedantic about this, and gosh darn it, I forgot to go and annotate this thing. So there's no title, there's no axes limits. I've actually got a rectangular plot, and I like square plots, so you can laugh at me when you see me in person. I'd be happy to see you in person because I'm a little bit annoyed about lockdown now. So tell me, remind me when you see me that, hey, Ian, annotate your damn axes, and you'll be absolutely right. So here I've just counted with a histogram, 100 bins, the age of my companies, how many companies are old. We can see that most companies on this horribly unlabeled diagram, most companies are young. Few companies are 50 years old, but some companies actually go up. I think the oldest company is about 180, I think, years old. And it turns out it's inevitably a land management property-based company. That's the oldest extant company operating on the UK books. Now, what if, if I've got 4 million rows, fine, I can fit this into RAM. What if I've got hundreds of millions of rows? Well, then this column gets quite expensive. So I can take my column, I can do some descriptive statistics. Fine, I've got 4.5 million entries, float 64, so this is using 8 bytes per entry. What if I convert that with as type to a float 32, so using 4 bytes rather than 8 bytes, halving the RAM usage? If I do my descriptive statistics, I look at those results, they look pretty much the same. So I'm getting the same answers, but I'm using only half the RAM. And in fact, using these two columns, age years and age years are smaller, this one being the float 32 version, I asked for memory usage, and I can see that I was using 36 megabytes, and now I'm using 18 megabytes for these columns. Now you might say, hey, 36 megabytes, that's not a lot, and 18 megabytes, great, it's fine. But if I had 1,000 columns of 36 megabytes, suddenly I've got 36 gigabytes. That's more RAM than I have in my laptop, and I can't compute at that point. I'm busted, at least if I'm using Pandas in memory. But if I can convert that to float 32, and I've got 1,000 of these columns, and they take half the RAM, all of a sudden they fit into the RAM on my laptop, and I can carry on doing my work. We can even go a little bit further. We can actually use a float 16, and then we get from 36 megabytes to 18, and then down to 9 megabytes for that same column. There's a caveat there. Float 16 is actually interpreted in hardware, so it's actually quite slow for doing any numeric operations on. But if it's for a column that you don't really care about, but you've got a lot of it, and you want to compress it down to a smaller representation, then you can actually put it down to this float 16 and save quite a lot of RAM in the process. So if I compare my original data frame with the company status, this is the non-category version, this is the original string version, and age years, the float 64 column, I can see that it takes 760 megabytes, and that's using the data frame info with the option memory usage, which has an option for true or for deep, and deep introspects each object and each row of each object to see exactly what RAM is used. This is great for string columns where you want to find out how much RAM is used per string item. So that's 760 megabytes. And if I use my categorical version and my float 32 floating point column, then I get down to 460 megabytes. So not quite half, but a significant reduction in RAM usage for the same functionality, at least for the purposes of my analysis here. So that's really nice. There's a couple of easy ways to save RAM and get more into memory. Let's have a look at a couple of other ways of interrogating our data set and see if we can make them faster. So using the data frame query is a very common way to perform some kind of logical query to get a subset of our rows back. Query is a powerful operator One of the things we can do with query is use the app syntax. Using the app syntax, we don't have to hard code inside the string the value that we're putting into a query. Instead, this will introspect the local namespace, so it'll look outside of the local namespace and find target age, a variable encoded in Python, and then bring it into this query. So this is great, and query does quite a lot of work behind the scenes. This means it can be a little bit slow. So if I time a query, here I'm just hard coding age less than 5 years, so finding all the companies that are less than 5 years old. It takes nearly 800 milliseconds. So fine, we do a query on 4.5 million rows. It takes less than a second. That's great. But if I perform a regular mask, so this is the kind of the old standard way of doing it in Pandas. I use dfag is less than 5 to make a Boolean mask of trues and falses, and then I dereference by that. I get the same result back, the same number of rows back, the same data frame as a result, but in half the time. So this is one of those interesting bits about the use of Pandas. If you know where you want to go, you can think about different ways of representing your query, and then typically you can find ways of shaving off some time or even cutting things down by half, which is amazing. We can drop down to NumPy sometimes. So we'll look at some slides in just a moment on this. If I go to a numeric column, age years, and I ask Pandas to give me a sum, super common operation, here it takes 27 milliseconds, so fine, pretty quick. If I say, well, give me dot values, so give me the underlying NumPy array, and then on that NumPy array, calculate sum, which is all Pandas is doing in the first place. It's doing that dereferencing internally. Here I'm making it explicit because I'm specializing it, because I know I can specialize it. All of a sudden it runs 10 times faster. So that's pretty amazing. And it's great if we know that we can do that. It's all about knowing that we can specialize ahead of time. If we just switch back to the slides momentarily, here I'm looking at this is the Pandas operation. Here I'm doing Pandas column, so data frame column dot sum. I'm measuring with a clever bit of code written by James Powell, who some of you know, a great PyData supporter and a key Python core developer. If you go and look at his videos online, you'll learn deep secrets about Python in general. He wrote this bit of code to help me understand all the calls that happen behind an operation inside the numeric library. So here I'm looking at the calls happening behind the scenes on a sum on a column in Pandas. 25 files are touched, calling up 83 functions. So we get this quite complex network diagram. And we see things happening like on the right-hand side, we have queries to see, is NA, is it an ND array-like, is it an extension type? So Pandas trying to figure out how to delegate its operations based on the Pandas data types, the NumPy data types, and other data types that might be held in a series. And instead, if we get the series values, we get the NumPy array out, and we call sum. 18 files, 50 functions. There's a lot less work going on. And most of the work that's happening here is actually still Pandas getting the series to get the values out so that I can then call the specialized sum version out the other side. So it never hurts to have a little step back for a moment when you've been using timing on some slow bits of code to think, hey, is there a more specialized way I can do this operation because maybe things work faster? Here's another example. If I take that company name string, if I do the string operator to get the string operations out, and I count the number of spaces per string, so I've got these company names with white space in there, I count the number of spaces. This will be a surrogate for the number of words that I've got in a company name. And I get my results. So 2 spaces, 4 spaces, fine. If I time it, that takes 3.6 seconds. If instead of using the str delegator, I use an apply function, and I apply a regular Pandas string count, it takes 2.3 seconds, so 2/3 of the time. Another great speed up for a bit more specialized code again. And it's a bit weird sometimes to think, hey, I've got to drop back into Pandas some of the time and otherwise drop back into a regular bit of Python. But if you're doing operations on large data frames with many columns, it can be worth making these specializations to give ourselves a little speed up. Right, final example, we can take the number compiler to do a numeric operation. So here I'm going to define a regular Python function, which I'm going to apply to a column. I'm going to call it won the lottery. This is a fake function. It iterates a number of times based on the age of the company. If the company is 10 years old, it does 10 loops. And each time in the loop, it generates a random number. And it says, well, if it's in the top 0.9 to 1, so a 10% chance, then we've won the lottery, hooray, some kind of significant event occurs in the company. And if we don't win the lottery, we carry on iterating. So younger companies have less likelihood of winning a lottery event, some big big contract or whatever, and older companies have a much better chance of having this occur at least once. And we apply this to 4.5 million rows. That takes 9 seconds. That's really slow, right? 9 seconds to wait for that. From number, I can import ngit. This is the JIT, just-in-time compiler. The ngit is a no Python mode, so if JIT can't compile the code, it throws an error and it bails. If you use the regular JIT compiler, not ngit, but just the regular JIT, it will try to compile. And if it fails to compile, it will use the uncompiled code silently. And then you might not realize that you haven't actually got the compiled result in the background, which leads to some errors. If I use ngit, I put @ngit brackets around my function. It's exactly the same function, regular bit of Python here, and it works great on NumPy code as well. And then when I run that, it takes 2 seconds rather than 9 seconds. So a 5-fold speed up for 1 extra line of code. That's pretty amazing. So now I'll talk for 3 slides very briefly about Modin. Modin is a data frame accelerator specialized for pandas. It's an academic project. So this is an extension around pandas. It's not a rewrite of pandas, but it's a whole bunch of new code built on top of pandas with a fallback mode to pandas behind the scenes. This academic project aims to create an algebra for data frames. It's a young project. It aims to be a drop-in replacement, and this is the cool thing. So it should just work the same as your regular pandas code. It uses the mature Ray library for parallel computation. There's a Dask plugin as well. Ray and Dask are similar parallel accelerators. Their innovation is to take the columns that you can see on the right-hand side of the diagram and then split them into row blocks. And these row blocks and these columns can then be split up across multiple cores to be operated on in parallel, giving you potentially a huge speed up. Because it's drop-in, it's easy to experiment with. So here in the screenshot, I've generated an example with 500 million rows with a couple of random columns, 2 float64 columns and a Boolean column. And I do an operation, is not. So is there any missing data in one of my columns? I do it on regular Python. And that operation takes 0.7 seconds. I then make a data frame from my pandas data frame with Modin. I've called that PDMD. That makes a new data frame. I then call isNar on that as well. That operation takes 0.15 seconds. So that's over a 4 times speed up for no code change on your part. Now, it's not all lightness and happiness. In my experimentation and in talking to other people that have been using Modin, it seems there's a mixed performance story. So for small data frames, first of all, you're unlikely to see a benefit. For large data frames, you could see a benefit. They published a paper recently towards scalable data frame systems, and there's this intriguing graph in there showing in blue the regular pandas operation, as the data set size gets bigger, the execution time gets slower. There's these steep blue lines there. And then Modin is the gentle yellow line at the bottom. As the data set size gets bigger, the operation gets gently slower, but only gently. But look at those data set sizes. They go up to 250 gigabytes. These are huge Amazon machines they're using, not my 32 gigabyte laptop. So my 32 gig laptop really doesn't work in this kind of domain. So I posed a question. That's the diagram or the screenshots, top right. Questions for a conference talk, bug number 1390 on the Modin project. And I gave them some benchmarks that I generated on my machine. I said, hey, I'm not seeing much of a speed up. What's going on? And they gave some very thoughtful replies to explain where Modin could be of benefit in a project. And the key takeaway there was if you've got many columns, so tens, hundreds, thousands of columns, they can be parallelized. If you've got many cores and these large Amazon machines, you have tens or hundreds of cores, and you've got thousands of columns, that work can be parallelized in a way that Dask and regular pandas doesn't tend to parallelize. And so there you can see speed ups. And then one of the arguments they make is that you can just drop it in, try it. If it works, great. And if it doesn't work, then no harm. So I think it's an intriguing library that is worth an exploration. So I said that I would also give a little summary as to what's happening on one view of the British economy based on the underlying Companies House data. So I've been looking at this over the last few weeks, scraping the 4.5 million companies, scraping because you can get a download of active companies, but you miss the dissolved ones. I wanted to see the dissolved ones, so I had to go and scrape all of that. Then I've been doing various bits of modeling, and we see a bit of a scary thing. And this is not, I'm not seeing this massively talked about anywhere. We see loads of COVID-19 stats. We're not seeing the effect on the economy behind the scenes. So every year, we see a certain number of companies being created in the United Kingdom. So the dark blue line is the last year and a half of the data. Every January, we see few companies being created in the UK. It's Christmas, no one's making companies. That's totally cool. That's Christmas there, this is Christmas here. Every Christmas, nobody's filing new companies. In the first 3 months of the year, we come out of Christmas, the new year starting. Every year we see a big bounce. If I go back 10 years and then overlay 10 years worth of data, in the first 3 months of the year, we see a huge bounce up in company creations. Great. Then for the summer, it drops down a little bit, and then it's fairly stable across all of summer. And then we get to winter and December, and then it drops down for Christmas. That's a very normal pattern going back 10 years. This year, we see the bounce up to March, and then all of a sudden, we see an uncharacteristic drop down just when the pandemic is hitting and we've locked down the economy. So this is entirely sensible. We can understand that kind of result. We don't know where it goes, of course. We don't know what this is going to do to our economy and other economies around the world. And what I find quite interesting here is by downloading this data from Companies House and using a tool like Pandas and messing around with making some operations go a bit faster, I can do lots of dynamic querying to see what the heck's happening with the engine behind our economy. So if you're curious about this, I would encourage you to also go and download the Companies House public data and have a play around with this. So let's wrap up. If you have a very big data frame, I think mode-in is worth a punt. It may make your operations go slower. You may see no speed up. You may see a good speed up. It's worth a go. If you're just using regular pandas, there are various things you can do to make it run faster. So you can do things like switch to a category data type, in which case a lot of your operations will be faster and they'll consume less RAM, and less RAM is better anyway for speed. You can look at different ways of implementing your functions. Things tend to work faster. There's a very nice library called Swifter, which in one line will take a regular apply function, which tends to work single core, and it will make it work on as many cores as you've got. It doesn't guarantee a speed up. Sometimes there are overheads that negate any speed up. But if you've got a slow operation, so a function that you're applying that's quite slow, and it can run it in parallel across multiple rows in blocks, it will do that with Dask in the background. I didn't show it here in this talk. But if you do lots of applies and they run slowly for you, look up Swifter. It tends to make your code just run faster for one line of effort. A bit like Number, one line of effort, things run faster. So I've been giving a couple of talks on this recently because I finished writing the next version of my book. So on my blog, there's a bunch of talks and links to code, and then these slides will be up on my blog as well. I've also got an email list, my thoughts and jobs email list, linked to my blog, and I give tips in there, so that might be interesting to you. If I've taught you something new, one thing I ask when I give public talks, if I've taught you something new, send me a postcard. I've got a wall of postcards. They make me happy. They make me realize that putting my time into giving talks is a useful thing. So write me a postcard. Tell me what you learned on the back of it. That's a bit of feedback for me to tell me what's interesting. And I think that's it for me. Thank you very much. And I'm happy to take questions if there are any. Or I would happily talk to you in person when we're allowed to get back into the same room. Thank you.
Thanks a lot, Ian. That was great.
You're very welcome.
A lot of really interesting stuff there that we wouldn't necessarily be able to think of without trying to find it. Yeah, so I guess are there any questions from the audience in the chat or in the Slido? Okay, we'll give you a chance to think about that for a moment.
No, I think all the questions in Slido are about TensorFlow probability. So that was the. I mean, that was certainly a very cool presentation that Paige gave us there. With a very interesting set of tools.
You do deep learning, getting all of the hype.
Well, yeah, new capabilities. That's always the interesting thing. I mean, Pandas frustratingly just kind of gets in the way of a bunch of that data prep when things go a bit slow. But I hope some of the techniques mentioned here can be useful there. I'll just add as an echo that John's lightning talk. Those tools that he mentioned are very good both for productivity, things like Black in the Notebook. They make you more highly performant as a developer, which is a great thing. And JobLib is a great tool, and it tends to just work. Particularly, there's one thing that John didn't show, and that's the parallelized execution. So you can make a function run multi-core, and it will run that function on different streams of data across all of your cores, and it can cache the results at the same time, and that's what John showed. And that multi-core execution, it's got a weird one line of syntax. I actually spent about 3 pages in my book explaining this one line of weird delayed syntax, because it's really hard to get your head around it. But then your code runs 4 times faster on a 4-core laptop. And that's brilliant. It just runs for free faster. And you can switch it back to a single core for debugging, so you can step in with a breakpoint and step over the code. So I really rate joblib, and that's a nice thing to make regular Python code and analytical code run quicker.
Yeah, I would definitely agree with that. I've used joblib multi-core processing in production, and from going from having no idea what was happening to getting I think 8 times production because of the machine we're running on in very little time at all. It's fantastic.
Absolutely, yeah. Well, and the other one is the one I mentioned here on the I'm annoyed that I didn't leave it in the demo notebook, Swifter. If you're doing apply in Pandas and you've got 1 million rows and you tell Swifter to use 2 cores, then it will do 2 500,000 row blocks and run the code on 2 cores, and then you get the result in half the time. And if you've got 8 cores, you'll get it in 1/8 of the time. That's brilliant for 1 line of effort. So yeah, that makes your apply running parallel. That's great.
I owe you a postcard.
I'll happily take postcards. I like postcards. They make me happy.
We've got a couple of questions now in the Slido. First from Manny, I hope I'm pronouncing your name right. Ian, do you have any vectorization-like examples to show speedups, and also showing them used in comparison with other frameworks, libraries, and tools?
No, well, do I have any vectorization? I have no vectorization examples to hand. Actually, in my course recently, we did work through, I'm trying to think what I covered there for the vectorization examples. I think in my course, I was working through things like a regular pure Python standard deviation function, and then implementing it in Python, but with NumPy, compiling it with Number, where it goes a lot faster, of course, vectorizing it, and then and Manny, if you're the Manny that I've been talking with on LinkedIn, I think I might have mentioned the NumExpr library lets you take your vectorized code and compile it for more memory efficient accesses. That's NumExpr. You have to rewrite your code and then it interprets it. It's slightly weird. It's like a mini compiler, and then it will take your vectorized operations. I've got an example in my book on like a 10 million element vector doing a cross entropy calculation, so some logs and multiplies, and then doing that with NumExpr, and you get a significant speed up over doing it in a regular vectorized fashion, because regular vectorized NumPy code is not memory. It's not super memory efficient. It's somewhat memory efficient, but it doesn't respect the caches in modern Intel and AMD hardware. So when you've got your 6 megabyte cache and then your level 2 and your level 1 caches, NumExpr tries to compile operations to get huge arrays like megabytes or gigabytes of data and get them in chunks which will fit inside your level 3 or level 2 cache, so that the operations run much faster. And it turns out, we were discussing this with some of the colleagues on the course, you can do a similar thing with the Number compiler as well. So Number and NumExpr on vectorized operations can give you very similar results. And Number has the intriguing operation that's just being better supported now for automated parallelization, where it will turn on OpenMP support in the background, at which point it'll run on multi-core for free, even though you've written a single core expression. Number just compiles it and makes that happen. It's a bit finicky as to when it will work. It will work, but it might run slower, and if you have to kind of phrase your code in a way that makes it run appropriately parallel. And if you want to go down another level, you can use Cython, and then with Cython you can control your OpenMP parallelism on your vectorized operations, and then you can really properly exploit multiple cores. And I've got an example of that with Julius, I think, in my book. But one thing to also bear in mind here is, and I love going all the way down to like layer 3 or level 3 cache semantics and making sure things are optimized. Brilliant. Only it tends to lead to unsupportable code that only you understand today that you won't really understand tomorrow. And trying to find a pragmatic point, considering being a highly performant developer. So where's the pragmatic point where I get enough of a speed up such that I can maintain my code in the future and get on with the rest of my work, and my team can work on my code as well. It's brilliant to go all the way down with, say, Cython and customized code and whatever else. Number's a pretty good sweet spot, actually. There's a lot of the stuff that you need in one line with a little bit of messing around with the code, and then it just tends to work. So that's my long rambling suggestion that for vectorized operations, look at number and wrap your vectorized operations with some number, and you might just find it goes faster.
Thanks, Ian. That was incredibly detailed.
Yeah, probably a bit too detailed there, sorry.
My mind's a little bit blown right there. That's fantastic. So a question from Nico, which is something I think we probably all dealt with. How would you suggest improving performance when reading really big CSV files?
Interestingly, the main Modin use case and the graph that they've shown off all the time whenever they talk about how to make your code faster with Modin is their read CSV example. So Modin definitely does performance improvements for reading in CSV files, and then you can convert that data back into a regular data frame if you want, rather than having it as a Modin data frame. Ahead of time, if you know the data types, you can, so if you've got, say, thousands of columns, and then Pandas is just loading in the raw bytes of that data frame. It reads ahead a certain distance, then it tries to guess what the data type is, so the most common basic data type for any particular column. For example, integers, if it encounters an NA, then it knows that it has to take a float representation, which will allow nans in there. If it looks like dates all the way through rather than strings, then it will know that it'll be a date time version, perhaps, if you've enabled the date time parsing. And if there are a mix of numbers and then the row 1,000,000, there's some strings, it knows that it can't just represent them as numbers, it has to use strings for the whole thing. But if you can specify the D types up ahead, so you can give it a dictionary, then it doesn't have to do the introspection and the guessing. It can just do that in a single pass. You can enable date time parsing on the load as well, and that can save a bit of time. I've done some experiments on this. I found that it doesn't actually save a lot of time, it just saves a bit of time. And if you can't guarantee that the next data frame you get has exactly the same column D types as the ones you've been working on so far, then maybe guessing ahead of time is a bit problematic. The other thing you can do is to do a bit of pre-processing, take your CSV and turn it into a file format like Parquet. And once it's in Parquet, then it's in a binary compressed format, probably compressed with the Snappy engine in the background. And that should load in quicker. It does mean you have to do some pre-processing. But if you do pre-processing, then you can do some data type validation. You can check your ranges are good. You can check that all of your distinct ordinals are in the right range, whatever else. And then having validated your data set, you can then save it out as a Parquet file. Then you load in your Parquet file for processing. It loads in quicker. You could even share that with Modin and others. They all use Parquet behind the scenes, or Dask or Vakes or the other tools that are out there. Parquet is not a bad data format to think of when converting your data to just get past reading in lots of bytes as a CSV file.
Well, that's great. Thank you. Yeah, a bunch of things can apply relatively easily. Mm-hmm. All of your materials can be shared online, right, Ian?
Yep, absolutely. So these slides will go up onto my blog. The notebook I've used here is the same as the one that I used for PyData Budapest. That included a Dask demo. That's already online, so I'll just link it all together and then we can share it here.
Excellent. Yeah, we'll make sure that we share those links with the video. We share those links on Twitter and everything else like that.
Mm-hmm. Perfect.
Yeah, so I think that brings us to a conclusion for the day. Thank you very much to all of our speakers, Sam, Ian, John, especially Paige and Ian, who's some really fantastic talks and kind of blown me away with some things we could do I had no idea about. Yeah, and thank you to everyone for joining.
Adam as well. Don't forget Adam. He's somewhere in the background.
Adam, sorry, Adam. Oh, that's the second time I've done that.
I'll extend my thanks to the Manchester team for hosting and making this happen. It's brilliant. Thank you very much for supporting our PyData UK ecosystem by bringing this together. It is much appreciated. So yeah, I say thanks from London, but thanks from everyone. It's brilliant. Well done.
Thanks, Ian. Yeah, and thank you everyone for joining us. Hopefully we'll see you next time. Bye.
Cheers.